Today we're going to do H-2 trigonometry ratios. Our objectives: find the sine, cosine, and tangent of an acute angle. Use trigonometry ratios to find side lengths in right triangles and to solve real-world problems. Okay, by the angle-angle similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with the same acute angle measure. Okay, so we've got three different triangles here. They're all right triangles. They all have an acute measure or an acute angle of 32 degrees. So, triangle ABC is similar to triangle DEF, which is similar to triangle XYZ. And the corresponding sides are proportional. These are trigonometry ratios. A trigonometry ratio is a ratio of two sides of a right triangle. So you must have a right triangle. Okay, so here are your ratios. The sine of an angle is the ratio of the length of the leg opposite the angle. Okay, so here's something that helps me. And in class tomorrow, I'll show you a video, and then I'll get it out on my website of what will help you. Okay, so Alright, so what this means is sine is opposite hypotenuse. So the sine of A is A over C, opposite hypotenuse. Sine of B is opposite over hypotenuse, B over C. Okay? Can't use that right angle there. Using the acute angles. Cosine, adjacent over hypotenuse, adjacent over hypotenuse. Cosine of A, adjacent, B over C. Cosine of B, adjacent, A over C. Tangent is opposite over adjacent. Tangent of A, opposite, adjacent. Tangent of B, opposite, adjacent. SOHCAHTOA is just an acronym to help you memorize the trig ratios. Okay, so let's look at this. The sine of J. Alright, so sine is opposite over hypotenuse. Here's angle J. So the sine of J, opposite, is 60. Hypotenuse of this right triangle is 61. Okay, round to the nearest hundredth. 60 divided by 61 is going to give you approximately 0.98. Okay. Cosine is adjacent over hypotenuse. Okay? So cosine of J right here, adjacent is 11, hypotenuse is 61. So when you divide that out and simplify, you get approximately 1800ths. Tangent is opposite over adjacent. So tangent of K, opposite is 11, adjacent is 60. And when you simplify that out, you get approximately the same thing, 1800ths. All right, let's see you do these three on your own. Okay, use a special right triangle to write cosine of 30 degrees as a fraction. Okay, so remember our 30, 60, 90? We want to find the cosine of 30. All right, so remember cosine is adjacent over hypotenuse. So the cosine of 30 degrees is going to be adjacent is s square root of 3 over hypotenuse, which is 2s. Simplify. I can cancel out those s's, so I have the square root of 3 over 2. And then use a special right triangle to write the tangent of 45 degrees as a fraction. So remember our 45-45 rule? So if this is an isosceles triangle, we have side, side, and we have 2 times the square root of that side. I think I got that wrong, guys. I think that's s square root 2. Okay, so doesn't really matter though because 45 is right here. So if we take this angle right here, we're trying to find the tangent. Remember, tangent is opposite over adjacent. So opposite this is s, adjacent is s. So the tangent of a 45-degree angle is 1. All right, need to make sure you all can use your calculators. I don't have the calculators on my smart board, so make sure that you have your calculator. Make sure that it is in the degree mode, which it should already be, and you find your sign button. So use your calculator to practice the trig ratios. Make sure you round to the nearest hundredth. Okay? So when you keyed in your calculator, you're going to hit sign. This first parenthesis is going to come up, and then key in 52. Make sure you end the parentheses, and you're going to get this. Round to the nearest hundredth. So the sine of 52 degrees is approximately 79 hundredths. So let's see you practice using your calculator. This is what you should get. Okay, very important before we go on. Do not round until the final step of your answer. Use the values of the trig ratios provided by your calculator. So try to keep that in your memory. Okay, we are going to find the measurement of BC. This right here. Okay, so we have an angle measure there, angle B. All right, and what measurements do we need? Well, we have opposite adjacent. Opposite adjacent is your tangent ratio. So what we can do is we can find the tangent of 15 degrees, and that's going to equal 10.2 over our BC. Okay. We need to cancel out this BC right here. So if I multiply the right side by BC, I can cancel that out. Remember, what you do to one side, you must do to the other. So right now I have BC times the tangent of 15 degrees equals 10.2. Well, we're solving for BC. So I need to get rid of the tangent. Don't key it in and get the number yet. I need to get rid of the tangent of 15 degrees. Okay? This cancels out. Therefore, BC equals 10.2 divided by the tangent of 15 degrees. So, with your calculator, key in 10.2 divided by, inside parentheses, the tangent of 15 degrees, and you're going to get approximately, we want to round to the nearest hundredth, 38.07 feet. Have to be as precise as possible. So if you're not coming up with what I'm getting here, make sure you see me in class because you should have exactly 38 7/100. All right, next one, find the length. we're going to find QR, which is this right here. Okay, we have an angle measure, P. So we have, what is that? Opposite hypotenuse. So that is sine. So we can take the sine of 63 degrees, which is the opposite, which is our QR, over 12.9. Okay, solve it like an equation. Multiply both sides by 12.9. So I have the sine of 63 degrees times 12.9 equals the measurement of QR. Key all this in your calculator. Then, at the very end, round to the nearest hundredth, and you should get 11 and 49 hundredths, and we're talking about centimeters. Okay, I'm going to be quiet. Let you do this one on your own. Okay, to save on time, we're going to skip this one so I don't have to do a part 2, and let's look at this one quickly. Okay, find AC, the length of the ramp, to the nearest hundredth of a foot. I need to give you some information. AB is 1.2 feet, and angle C equals 4.8 degrees. Okay. So what we have here is a perpendicular line. So right here, off a little bit, is a right angle. So what I can do is I can use the sine, which is opposite over hypotenuse. Okay. So the sine of angle C, sine of 4.8 degrees, equals opposite, which is AB, over hypotenuse, which is what we're trying to solve for, AC. Okay, so this is where you multiply both sides by AC, and then divide by the sine of 48, so take 1.2, and divide by the sine of, actually it's 4.8, make sure you use that in parentheses, and you're going to get approximately 14 and 34 hundredths, and we're talking about feet. Okay, guys, that's it. 8-2.